Welcome, friends. In today's session, we are looking at oxidation numbers. And I believe those who watched the first lesson about oxidation and reduction reactions, you have been able to go through, and this will be helping us in the continuation to that lesson. Let's start with what oxidation number is. So, saying that the oxidation number or oxidation state of an element in a chemical compound is the charge it would have if electrons were completely transferred rather than shared. And we're saying it helps in determining how electrons are gained or lost in redox reactions. So that is what we call an oxidation number or oxidation state of an element. Now, there are some key points about oxidation number. Number one, we are saying oxidation number represents the degree of oxidation, in brackets, loss of electrons of an atom in a compound. And we are saying that the oxidation number can either be positive, it can be negative, or even it can be zero. We shall be looking at that as we look at some examples. We are also saying it helps in balancing redox reactions and identifying oxidizing and reducing agents. So that is the importance of the oxidation numbers. In our next session, we shall be looking at different redox reactions, and we'll be able to identify oxidizing and reducing agents using oxidation numbers. Now we're saying we have some rules for assigning oxidation numbers, rules that we follow when we're assigning oxidation numbers. So before we go there, we're saying that oxidation numbers or oxidation states, they help in tracking electron transfer in redox reaction. So when we follow these rules to assign oxidation numbers correctly. Number one is free elements. So we're saying that oxidation number of any free or uncombined element is zero. That is something we need to take note. The free element or uncombined element, its oxidation number is zero. For example, we have oxygen. So oxygen in this format, uncombined, only oxygen, its oxidation number is zero. Nitrogen, the same case. Sulfur, the same case. Sodium, it's the same. Okay, so their oxidation number is equal to zero. Number two, simple ions. So the oxidation number of monoatomic ions or simple ions is equal to its charge. Simple ions, just small ions, we are saying that their charge is equal to their oxidation numbers. For example, we have sodium ion. Sodium ion having a positive charge of 1, which means its oxidation number is positive 1. Chloride ion having a charge of negative 1, therefore its oxidation number is negative 1. Then iron 3, its oxidation number is positive 3. So we're saying that the oxidation number of any simple ion is equal to its charge. Now, number 3, we're saying that for oxygen generally has oxidation number of negative 2, except when it is in peroxides like hydrogen peroxide, like sodium peroxide, that's where it is negative 1. But generally, for oxygen, it has oxidation number of negative 2. Another exception is when oxygen is in compounds with fluorine, like oxygen fluoride. So in this case, its oxidation number is positive 2. So those are some of the exceptions when oxygen is in peroxides, and when oxygen is in compounds with fluorine. That's when the oxidation numbers of oxygen can change, but generally its oxidation number is -2. Now for hydrogen, hydrogen has oxidation number of +1 in most compounds, but -1 in metal hydrides like sodium hydride, calcium hydride. That's so where hydrogen is combined with a metal, its oxidation number is -1. But in most compounds, hydrogen has oxidation number of +1. Please keep on pausing and you note down, because these rules are very important even as we are looking at our next lesson. So I want you to pay much attention and note them down very well. Keep on pausing and then you'll be able to move together. Fluorine. So for fluorine always has an oxidation number of -1 in compounds. Then other halogens like chlorine, bromine, iodine usually have -1 unless bonded to oxygen and fluorine. So usually they have oxidation number of -1. Number 7, we are talking about the sum of oxidation numbers. Please, let's take note of this, the sum of oxidation numbers. So we are saying that in a neutral molecule, the sum of oxidation numbers must be 0. A neutral molecule is a molecule which is having no charge. So we are saying that the sum of oxidation number is equal to 0. For example, when you look at water, it is a neutral molecule. It doesn't have any charge. So when you add the oxidation numbers of these elements, hydrogen and oxygen, you'll get a 0. For example, hydrogen has oxidation number of +1. So 2 times +1 plus -2 for oxygen, you get a 0. Then in polyatomic ion, where we have more than 2 atoms, but that compound has an ion charge. So we're saying the sum of oxidation numbers must equal the ion's charge. So the charge on that ion is equal to the sum of the oxidation numbers. For example, let's have a look at sulfate. So for sulfate ion, its charge is -2. So when you add oxidation numbers of this sulfur and oxygen, you'll be able to get -2. So the sum of oxidation numbers must equal to the ion's charge. So they have shown you sulfur +6, oxygen -2 each. So it becomes +6 plus 4 times -2 for oxygen, and the answer is -2. So that helps us even when we are calculating different numbers. Then metals in compounds. So for group 1 metals like lithium, sodium, potassium, and others, they always have +1 oxidation state. For group 2 metals, beryllium, magnesium, calcium, they always have +2 oxidation state. Then for transition metals can have multiple oxidation states. E.g., we have iron 2, iron 3. Whenever you see iron 2, it means it has oxidation state of +2. Iron 3, it has oxidation state of +3. We shall look at an example of looking at manganese. For manganese also has different oxidation numbers. So we shall be able to look at that in our example. Then number 9, oxidation number of carbon. Then we are saying that for carbon varies depending on the compound. E.g., it is -4 in methane, it is +4 in carbon dioxide. So depending on the compound it is in, its oxidation numbers can always change. Now we are saying that following these rules ensures correct oxidation number assignments in chemical reactions and redox processes. Let's have a look at some example, and then others will be able to go through them. Example, what is oxidation number of manganese in the following? So we have potassium manganate. What is the oxidation number of? I believe for these other ones we know, because it said for group 1 metals they have an oxidation number of +1. Oxygen has oxidation number of -2. Now for manganese we don't know. But also there's something we have looked at in the rules, that for a neutral compound the sum of oxidation numbers is equal to 0. So since it is equal to 0, so we can just say let the oxidation number of manganese be Y, because we don't know it. For potassium we know. For oxygen we know. So when let it to be Y, you can say 2 atoms of potassium times +1. This is oxidation number of potassium, plus Y, which is for manganese, plus 4 atoms of oxygen times -2, oxidation number of oxygen. It is equal to 0. Why equal to 0? Because the sum of oxidation number of a neutral compound equate it to 0. So here it becomes 2 times 1, which is 2, plus Y. 4 times -8, you get -8. So which means 8 minus 2 minus 8, you get Y minus 6 equal to 0. And finally our Y is equal to +6. So we can conclude and say, therefore, the oxidation number of manganese is +6. Then when we look at manganese oxide, you can say let the oxidation number of manganese be M. Oxidation number of manganese be M, and then you can say 2 atoms of manganese times M plus 3 atoms of oxygen times -2, which is oxidation number of oxygen, equal to 0. So this becomes 2M plus -6 equal to 0, and then we have 2M minus 6 equal to 0. So when you make M the subject, remain with +3. Therefore, the oxidation number of manganese is +3. So thank you for watching. Let's meet in our next session as we continue to look at oxidation and reduction reactions, as we see the redox reaction. Let's meet in the next session. Have a blessed time.